So we did an example problem where someone just dropped something. Now let's do another problem. Let's say that we have someone here and they're up here and they have an object and they throw it downwards. So we throw it downwards with initial velocity of 2 meters per second, and let's say the distance is 2 meters above the ground. So this is like a basketball player, and he throws something downwards 2 meters per second, 2 meters per second at a distance of 2 meters. And I want to know how long does it take to hit the ground and how fast is it moving. And so you naively might say that, well, it's 2 meters per second and 2 meters, so that would be 1 second. And if you did that, your answer would be totally wrong. Okay, and that's because it's not moving at constant velocity here. It's speeding up as it goes because gravity is actually pulling on it. Even though you're throwing it downwards, gravity is pulling on it, and that makes it go even faster. And so it's going to hit the ground in even less time. So, do the same thing as before. I'm going to put my origin at the top and say that the acceleration, gravity is down. My V naught is now going to be in that direction. So, so I'm going to say that x equals x naught plus V naught t plus 1/2 AT squared. Okay, so x naught is going to be 0. So this would be V naught t plus 1/2 GT squared. Okay. I need to solve for t. Well, that's a quadratic equation. So let's put it in the quadratic form. 1/2 GT squared plus V naught t minus x equals 0. So the quadratic formula. T equals minus V naught plus or minus square root of V naught squared minus 4 times 1/2 g times negative x divided by 2 times 1/2 g. So in other words, t equals, make this look neater, minus V naught plus or minus square root V naught squared plus 2gx divided by g. Okay. So now we plug in numbers. And so we plug in the numbers that we had. And so that's going to be minus 2 meters per second, square root of 2 meter per second squared, plus 2 9.81 meter per second squared times 2 meters. I'm being a little sloppy here with writing the significant figures. I know these are supposed to all be 3 significant figures here, but I'm running out of room here. Divided by 9.81 meter per second squared. Okay, this is plus or minus up here. And so that means that we're going to have 2 answers, quadratic equation. So the 2 answers are 0.466 seconds and a negative 0.875 seconds. And so now the question is, which of these 2 answers is the correct answer? Well, negative time means before the problem even started. That's not realistic. So we're finding out how long after we threw it, it hits the ground. So that's going to be the positive number right here. And so that is the answer, 0.466 seconds. So the next question I had was, how fast is it moving when it hits the ground? So the velocity is V naught plus AT. Once again, I put the origin at the top. I said that V naught is down, the acceleration is that way, so the acceleration is positive g. Okay, so V is going to be V naught plus GT. So V is going to be equal to 2 meters per second plus 9.81 meter per second squared times 0.466 seconds. So V comes out to be 6.57 meters per second. Okay, because I said down is positive, this positive number here means it's moving down when it hits the ground. All right, so that's an extension of that problem similar to what we just did. Okay, except now it has initial velocity.